is the process of visiting each element, performing some operation exactly one. That's what we are doing here. Same. So to traverse through the linked list, what are we have to do? What are the first steps to be followed? First, we have to move to the first node. So start contains address of the first node. That is how to begin with, we move to the first node and fetch the data from the node and perform the required operation depending on data type. So because each node will be having two fields and get data. So data from the node and perform the operation required depending on which data type. So depending on data types, you can perform the operation. Then move to the next node. So advance to the pointer because node contains the one more address of the next node, one more field where we have address of the next. So the same process is repeated for all the nodes. So that's how the traversing is performed. So we'll take an algorithm, then you are able to understand. This is what we have to do. First we move to the first node, fetch the data from the first node and perform the required operation, then advance to the next node. Repeat this two process until, that is step 2 and step 3, until we visit all the nodes. So there are no nodes or left, so there we stop. So let us we take an algorithm now. So let, as usual, we take this one algorithm, traverse through the linked list. So always start gives the address of the first node and the pointer p I'm using. So temporarily used to visit all the nodes. So from beginning to the end of the linked list. So from beginning to the end of, that's a traversing of linked list. Okay. So let us we take this p is equal to start. So what does start means? So start always contains address of the first element. Let us take an example of, let me write a simple way. So this is in the first node. I think it's, let me write. So we'll take a first node. This is the first node for understanding. We'll write this is the first node and we have a next node here. Okay. We'll take only 4 nodes. Okay. And this is a one more node. Okay. We'll take 3, one more. I think already you know about these things. So what does start mean? So let me write here some numbers. 10. Need not be any number. 20. 30, something like, and this contains, I'll write n only, which is null. That's the end of the list. So where is this one? This address is a start. So what does start means? Start contains address of the first node. So that is what we are going to discuss now. So this start what we are talking about is this one. So which contains address of 10. That's address. So now what is this statement does? So P is also pointing to this node. So if it is some number address, it's no problem. Let me write. If it is its address is something like, let me write 1, 2, 3, 4. So its address is 1, 2, 3, 4. It is something like 4, 5, 6, 4, 5, 6, 1, 2, 3, 1, 0. It is 5, 4. This just address randomly I write. So what is this 4, 5 will be here? Okay. So this 4, 5, 6, 1, which will be the address of this one. So 2, 3, 1, 0. So 2, 3, 1, 0. So what is this? 5, 4, 2, 0. I think you make it clear. So this addresses are kept here. So that's how. So what is start means? 1, 2, 3, 4. That will be copied to P. What is P is now? Also 1, 2, 3, 4. So this is how they are going to store pointing now. So P start 1, 2, 3, 4. So P definitely 1, 2, 3, 4 not equal to null. So get the data of P. So this is a data field. So data of P is 10. Perform some operation if you want input or output or any update, modify. So performing this. So data of P, that is how we are doing it. So data of P means we are applying some process on the data which is stored at 1, 2, 3, 4. So data of P, this is an algorithm. So next what we have to do means we have to move to the next node. So how do you move to the next node means, so that's how we are traversing now. Let us we go with the another link. So that is why. So what is the link of field of this one is 4561. So that now P value is replaced by, you can see now, so P value is replaced by now link of P 4561. So now it is changed. So this value becomes 4561. So 4561 not equal to null. So now we'll go to data field of 4561 is this one 20. So we apply some process on this. Then what we do, we update. So P is equal to link of P. So what is the link of P now? We have a link of P is, so we have a link field of P 2310. So link of P is 2310. So let me write 2310. So 2310 not equal to null. 2310 not equal to null. So data of 2310 we have a 30 apply. So data field of 2310 apply some process. Now we visited this element. Okay. Next link field of 2310 is copied to P. So what is P now? So the P value is changing. So P value is link field 5420. So now it becomes 5420. So this becomes 5420, which is not null. Correct? 550 is not null. Apply some process on that data. So what is that data? Is 40. We perform some operation. So we visited the next node. So next what we do, we replace the P by link of P. So what is the link of P now? You can see there the link of P is null. So null not equal to null becomes false, weak quit. So it becomes null now. If you want you can write or you can understand, so no problem. So this becomes null. I think you can understand here. Okay. So null not equal to null is false, we quit. So what this step did means we visited each node and we apply some process on data field of each node exactly once. It's like we traversed, we visited all one by one. How it is possible means we took a temporary pointer P and then using this P, so we visited this and we visited this and then we visited and then we visited and it is stopped. So this is how traversing operation is or algorithm is performed. Whenever we think of traversing with a linked list means a temporary pointer has to be created. With the temporary pointers we have to move to all the nodes. So this is how what we call traversing algorithm is performed. Now this is how traversing can be performed with the linked list. So let us learn something about memory allocation to the linked list. Already we know about memory is allocated from the pre-full, that is availability list, or there is always a memory from the computer memory. So there we'll take memory from the free list or free storage. That free storage is called availability list. So once its usage is over again, it has to be send it back to the availability list. That's why we use a dynamic memory allocation where we have a what we call new and delete operators. They are used to perform the dynamic allocation of memory and dynamic deallocation of memory. Already I have told about what's the necessity of allocation and deallocation of memory. So now let us learn something about memory allocation to the linked list. That's where do you get memory for the linked list, because this is done during the execution of program. That's why we have to think of memory which is maintained by the operating system for dynamic memory allocation. So that is what done by, that's where we'll get the memory using the new operator. And this is very important. Whenever the usage is over, again the memory free has to be reinserted into the availability list so that that can be used for the future use. So computer memory is a limited resource. Of course, we have already known this thing. So therefore, some mechanism required where the memory space of deleted nodes becomes available for the future use. Yes, of course. That's one of the most important aspects of computers. Whenever we use the memory, so after usage, it has to be becomes available for the future use. In real life also we do. So when we take food at home, so after the usage of having food, the plates are thrown, no, we keep and we make you wash it and then keep it for the future use. Exactly the same way the memory has to be reused again. So this how it is done means it has to be inserted into the linked list. The deleted node should inserted into the linked list. The operating system of the computer maintains the special list called availability list or avail list that contains only unused or deleted nodes. So whenever its usage is over, it is deleted and we are going to form one more list. That's operating system is forming the list. So that list is called availability list or avail list. So avail list is a linked list that contains only unused nodes. So whenever node is deleted from the linked list, its memory is added to the availability list. And whenever node is to be inserted into the linked list, a node is deleted from the availability list and it is inserted into the linked list. Avail list is also called as a free storage list or free pool. Already we talked about free pool or storage list. So here that's what we are talking about. So this you don't need to worry about anything here in this case. So just you use the new and delete operator. So whenever you ask for the dynamic memory, so that memory is maintained by the operating system in the availability list. In the name of availability list, the operating system just handovers the memory according to your requirements. So and also whenever we perform a delete operation, so this memory will be transferred back into the availability list by operating system. So just to use a new and then use a delete whenever the memory is needed for dynamic memory allocation. So now let us learn about insertion into the linked list. How do you insert a node into the linked list? So whenever inserting a node into the linked list, a node can be inserted in only if there is a free nodes available in the availability list. That's like talking about overflow. So if there is no free nodes are available, so then we cannot insert. So that's overflow condition. Overflow occurs, there are no free nodes available in the free store or availability list, then we call it as overflow. Anyhow, will not occur when we perform this insertion operation with the dynamic memory allocation. So whenever a node to be inserted, so there are three steps to be followed. So first, inserting node at the beginning of the list. Where do you want to insert? So possibility as the first node, or inserting at given position. So we'll give some position and given position, or maybe you are inserting at the end of the linked list. This already we have discussed a program. So creating linked list, appending at the end of the linked list. Anyhow, we learn all one by one. So to insert a node at the beginning of the link, first we'll go for the first one, beginning of the linked list. How do you insert the node as the beginning of the linked list? We take an example. Start is a pointer that contains memory address of the first node. As usual, always it contains address of the first node. To insert an item, this is what we are going to insert into the linked list. To do this, we follow the procedure. So first we have to create the new node. First we have to create a node. Just you can like imagine. So this is how we are going to, this is how you create. First create new node, and then this is a node. The second one, fill the data into the new node. That is, if it is item means, so just I'll write here item. So this has to be, that's how we have to fill it. And make this as a null. We have to make it as a null. This is the step of creating, adding the second step. So attach this newly created node to a start. So make this to the start. So start will come here. So the start, make start pointer here. And this replace the address of here by start. So that will connect as the beginning node. So make the new node as the starting node of the, we'll understand when we write when we go with algorithm. So we'll go with an algorithm. So very simple algorithm. So this algorithm insert a node at the beginning of the linked list. So P is equal to new node. So this is where we are creating, this is a new operating, you can think. So this is a node, is a data structure, what we are describing, structure type. So we are filling data of that new. So this is like just we created this one new node. So this new node, just imagine like this. So actually we do not have this one, just for simplicity's sake. You can imagine. So this is not there. Imagine. So actually earlier it was existing. Only the start was pointing to here. So 40, it is pointing to 40. Now what I did means, so I created a new node and then I inserted data which is 50 like this and this, and then I updated link of P. So if the start is this one. So very simple if you want to understand. Let me explain this and then we'll go with that. So link field of, we as usual insert the data, and link field of a newly created node we put it as start. So and then start is equal to P, that is a new address. Very simple. Let me explain with the values. So this is, let us assume it is something like 4510, its address, and its address is something like 223 something. So what was start means, so start having this address 4510, you can see here. So new is created. So what is P means? So what's the value of P? I think you can answer. And the value of P is, this is a new one, new node is a P. So it is 2345. So before this step, so this is now you created a new node which is, and I filled data for this 150, and then link field of start. So what is start earlier before this? So let me write. So start was 45. It was 4510. So there what we did means we copied to link field. So here I made that 4510. This is link of P 45. So this relation is established now. Correct. So now this is broken. So now what happens? This line does not exist. Okay. So now what happens? So the start is given. So nothing is there. So start, what he did, I made P. Start is equal to, what is P? 2340. So P becomes 2345. So when it becomes 2345, so start now is pointing to this because start contains the 2345. So now this is how the linked list is created. So 2345. So the new node which is I created is inserted as the first node. Very simple algorithm. So create new node. This is to create new node, dynamic memory allocation. It handovers the address like 2345. At this 2345, you add some item, that's a number, you're inserting some number. It is, in this case, it's a 50. And this link field, I told it's a null. So we replace that link field by the start node. That's a start address of the first node. This was the address of the first node that is copied here. So now make the start to pointer to this. So now start is the node which is created. So this was the list which we had. So now this becomes the first node. Actually the first node was 40. Now the first node becomes 50 after this. So this is how we inserting at the beginning of the linked list. There is a program to illustrate this, inserting node at the beginning of the linked list. Already this is exactly similar, but only thing is we have to remember, let us we go with the linked list class name. So class name is linked list. It has a member pointer to a structure which has two members. So one is data, another is link field. I think it's very simple. So we have only two fields as usual node. I think you are all familiar with. And then we use one by one. Let us take first one is we use three functions. One is actually four functions. So let me use color different. Yeah. So we have a linked list, constructor, member function, all are public, count, insert. So this is what we are going to discuss. So insert is more important. This is the algorithm we are going to implement. This already last class we have learned, or this also we have learned in the last class. So this is the insertion which is more important in this. Okay, this class, this is what we are trying to insert. So constructor, so it has the same name as that of the class, so linked list, and this is the scope resolution operator. So we are to begin with, the start contains address, nothing. So start is, there is nothing exists, so therefore start is equal to null. So as usually we initialize, if it is a normal variable, we initialize s is equal to 0, something like that. Exactly similar way, the linked list address, we make it as a null. So right now it's not pointing to anything. So next we go for the print. So traversing through the linked list, where we display that's now traversing also you can understood now in this program. So if start is equal to null, linked list is empty, I cannot perform anything, go back. So this is a very simple one. So otherwise what happens, linked list contains some element, let us we traverse through. As usual, we take a pointer, a new pointer, so node type, so temporary pointer is created and it is equal to start. As I told already, we discussed about p not equal to null, and we give some space or display the data like 10, 20, whatever we discussed. So the same thing, p data, so and p is equal to p of link. So it's very simple, no need to explain once again this one because already you are familiar with this. So it takes the first element and displays the data and then moves to the next element. And again, it is not null, display the second element and again moves to the third element, it repeats. When all the, let's apply some process we are discussing, this is the output. Output is data of p we wrote, the same thing here. So this is how we did it. So it's very simple. We'll take this example and you'll understand this automatically. Very simple. Just follow, create 4 nodes and apply this, what I explained, the same procedure you have to follow here. But it's a program, that is the algorithm, that's all. So now let us insertion. We'll take one more program, that's a program segment, the insertion. So how do you perform insertion operation? So new node, we'll take, this is actually a pointer variable name. So don't take this and this is a difference. So there is a space. So when there is a space means this node and this is the operator. So what is this one? Is the operator. So you have to be careful. This is the operator and this is a pointer. You could have take P also. Doesn't make difference, or PT or any other. So they took new node because they are creating a new node. So let us learn how to insert a new node into the linked list. So new node. So it's like just we are creating. So new node. It is created for understanding purpose I am writing here. So just it's a new node which has 2 fields. So one is data field, other is a link field. So there we add the data field as we know here. So data field is we add some number so which has received. So I'll copy that here. So data field num. Okay. And the link field I'll put start, so which already exists. I think you understood all the previous one, okay. And start is equal to, so new will be, this becomes a start. A simple one, we'll take main program example, then you'll understand. Inserted as the beginning node, very simple, nothing. This already exists some element, so add this element and like this, just blank I'll write. You can understand here, this is the first node, this is the second node, which was exist earlier, example, let it be no problem. So the start was pointing here, correct? So they are linked together like this and start was here. Now what I did means, I create a new node, I make here the start. Okay, and I took this start and I connected this start to this. I think this is much clear now. This is how the steps will do. First we enter data here, so that doesn't make difference, just number, some 10 or 20, whatever number it is. Then link field of the new one, so this link field we put start, which was here. And then we made start is equal to new node. So very simple. This is how, so it becomes the first node of the linked list. Very simple. So this counting is also last class we did, traversing through, visiting exactly once to perform, that is C++ operation we did. Take the first node, not equal to null, update, again we repeat. So display this. So we have 3 nodes, 4 nodes, depending on like that. And these are the functions are over. So they'll come back to the main function. So we have a main function. So here we think linked list creating an object, which is also pointer, very important. So we have a data type star variable name. So what is data type? A class. It's a pointer now. So object, an instance of class. So what is this? Again, it's a dynamic memory allocation. So we are taking a linked list, a class type of dynamic memory, and we have identified its address by obj. That's obj is a pointers to object. So this is an item, that's what we are going to insert. So there we wrote 10, number 10 or 20, whatever it is, it's a choice. You want to insert only one element, you can keep inserting as many as you want. That's a choice. Yes, your choice is yes means you keep inserting. That's why do you want to insert the beginning of the linked list? Yes. If your choice is yes means this is only interactive. So yes, so enter the item to be inserted. So when you say enter item to be inserted, like 10 you entered, so then we call the function. So this is the arrow symbol we used for accessing the members of the class, so using pointers. So now what we do, the function is called, so it goes to here. So here the num, what you enter like item, so item becomes this, if it is 20, so 20 is copied and this follows this and insert one more node here. So this is how you keep inserting from the beginning, one by one, so it's keep inserting and this is how it performs. I think a very simple program, and then we want to insert another after this insertion. Do you want to insert at the beginning, yes or no? If you press yes again, the control comes, your choice is y is equal to y, yes, enter another item, another 20. So if it is, you can imagine here only, so I'll write the first time your choice is yes, and I'll write closer here. So your choice is okay, and then you write, this is you called and you send 10. So this is created. And this is the first node, is the 10. Okay. Next your choice is again, insert as another node, yes. So insert as a first node, one more. So like this, 20. Want to insert one more? Yes. 30. Any number. Doesn't make so. Okay, this is how the keeping inserting at the beginning, as many as you want, inserting as the beginning of the node. To begin with, first we have start null, so inserted as the first node. Automatically it becomes null and start is pointed here. And then inserted and replaced like this. So this is how it is going to insert. So if you press choice no means this condition becomes false, we quit. So then we object print, it prints all the elements and counts how many exist. So this completes the program. So this is how we do the insertion algorithm. And I think it's very simple. And we'll continue with the next one more. This is an example they have given here. So do you want to insert the node as the beginning? Yes, you press Y. Yes means, so enter the element to be inserted. So 101 inserted at the beginning. So this is created like this. And 111 is created. Again you want to insert? Yes. So then means one more created and it becomes in front of it like this, which is 2, 2, 2. Do you want to insert again? Yes. One more is created. That's insert operation. So it is 3, 3, 3. Any number, whatever you want, you can give. and no means it stop, we quit. So displays all 3 3 2 2 1 1. So number of counts 1 2 3. This will be a null. Okay, I think you understood. This is how inserting at the beginning of the linked list. So inserting at the end of the linked list already we discussed. So move from the link field till last pointer, traversing. At the end we add the new node. That's all. Very simple this is. So first here we have to go with the link field. This is a wrong technique here. So this has to be replaced. In that place we have to write. So that is a link next. Here we have to write. You can take no problem. So next of P, while link of P not equal to null means we move to the last node and there we add a item and link field is replaced by the last one. So this is how we able to perform the inserting node at the end. So first traverse to the linked list. I think traversing already move to the like this. Let me write, this is the first node, this is the second node, this is the third node possibly existing. Okay, so this is a null usually, so null. So using P traverse. So after reaching here, what we do, what you create one more node you have created, because insertion means you have to create. So this is a new node. So here we have n, so new node. So link field you copy n and this you make it as a null. That's what it is. So I mean link field of it's null and data we inserted here something item and then link of n is null. So link of P here we copy n. So this line is established. I think you have that's understood. This is how we are going to insert an element into the linked list. I think it's very clear. It's not difficult at all. I think one more inserting at the given position that will continue in the next class.